Hello, everyone, and thanks for attending my presentation. Thank you also to the organizing team of the API Specifications Conference for giving me the opportunity to present here. My name is Jose, and today I want to talk about how we can leverage API documentation to deliver better and more reliable API integrations. But before I do that, let me introduce myself. My name is Jose, and I'm an independent contractor based in London. I work as a full stack developer, and for the past few years, I worked with many clients, helping them to build microservices platforms and API integrations. Along this journey, I made many mistakes, but I also learned a great deal of things about what it takes to build great microservices platforms and API integrations. The result of this journey is a book, which is published by Manning. The book is currently in development, but we are nearly at the end of the writing process, and it will be printed soon. The title of the book is Microservice APIs in Python. Although it's not yet printed, it's available through the Manning Early Access Program. And if you're interested in getting a copy of the book, you can use the following discount code, which is shown here in the slide, to get a 35% discount from the price. I'm also the co-founder of microapis.io. This is a website that I use, a platform to offer my consulting services, but it's also a platform where I'm building tools and frameworks that make it easier to build microservices and APIs. The first of these products is an API mocking service. It's very easy to use. All you need to do is come here to the website, to the API mocking page. You simply need to paste the API specification of your API in the input panel here. You click the mock this API button, and in return, you get a base server URL for your mock server, which you can use to start interacting with it. I love to connect with new people, and as a consultant, networking is really important for me. So if you would like to reach out to me, please feel free to do so in any of the following platforms: Twitter, GitHub, Medium, or LinkedIn. Now, what's the agenda for this presentation? So first of all, I want to say a few words about why API integrations are so complex and error-prone. Then I want to say a few things about what we can do to reduce the chances of API integration failure. In this context, I want to introduce the concept of documentation-driven development. I will explain what it is, how it works, why it matters, and how you can incorporate it into your own API development process. During this presentation, I'm going to use some codes. So if you're interested in checking out these codes, playing around with it, make some changes, tweak it, or just use it to try out any of the commands that I'm going to show during this presentation, please feel free to clone or fork the repository shown here in this slide. It contains the code that I used for this presentation. Now, why are API integrations so tricky? Well, let me illustrate this complexity by showing you the typical situation that I often find when I'm working with a client on an API integration. So typically, we will have a team working on the API server, and at the same time, we have a team working on the API client. Once work is done, at some point, we release the server, then we release the API client. We get the client talking to the server, and from the very first moment, the API integration typically fails. Now, there are many reasons why API integrations fail, but when it comes to the interface layer itself, there are at least three major factors that, in my experience, result in this kind of situation. The first of this factor is when we drive changes to the API or the design of the API exclusively from the point of view of the backend. The second factor is when we have misunderstandings between the client and server about how the API is supposed to work. And finally, an important factor is when we don't have robust validation of our implementation. Let me delve into each of these factors a little bit more in detail. So when we drive changes or the design of the API exclusively from the point of view of the backend, essentially what happens is we're not taking into account the requirements of our consumers when we build the API. This really shouldn't be like this, because as API developers, we are not building the API for ourselves, we're building it for our clients. So what the client development team needs for the API should be our most important concern when we are building the API. This approach is very common among teams who use frameworks that allow you to build your APIs with a code-first approach. So frameworks that are capable of generating the documentation directly from your code. Now, I'm not advocating against the use of these frameworks. Personally, I use them all the time. But what I'm saying is that before building your API, you should definitely talk to your API clients to understand what the requirements are and how you should build your API. Otherwise, we typically end up in situations where the API is a collection of random endpoints with random schemas, which is very difficult to understand and build integrations with for the API development team. The second factor is misunderstandings between the client and the server about what the API should be doing or how it's supposed to work. These kind of misunderstandings come in many forms and shapes. Could be a misunderstanding about what the expected format of one of our properties is, what the type of a property should be, or what are the optional fields in a payload. When these things are not clear, failures are likely to happen. So if certain fields are not coming in the expected format, the client is not going to process them correctly, and therefore it's going to fail. And the same for any other of these misunderstandings. Now, what causes these misunderstandings usually is the lack of proper API documentation. So typically, in many situations, what I see is teams are working with JSON examples. So these are just collection of examples of what the API is supposed to be returning. The problem with JSON examples is they're just that, examples. They are not really descriptions of what the API is supposed to be doing. Compare the example here between a JSON example and an actual description of what the payload for this schema looks like. The description is a lot more informative. It tells you the exact type of every property, and it tells you what the required fields are. Now, API integration failures at the beginning of the development process are so common that they've led me to think that there is a fundamental law of API integrations, which is that no API survives first contact with its client. Now, this may be the case, but we certainly can do things to improve the release process of our APIs and reduce the chances of API integration failures. The first thing we need is actual documentation. Once we have actual documentation, we can leverage the documentation to improve our API development process. So what exactly is documentation? And that depends on the type of API that you're building. So if you're working with a REST API, documentation is a specification written using the OpenAPI documentation standard. If it is a GraphQL API, you're looking to use the schema definition language. And if it is a gRPC type of API, you're looking to use protocol buffers. Every type of API has its own preferred documentation format, and you stand your best chances of delivering successful API integration if you use those standards. Because around those standards, often you will find a whole ecosystem of tools and frameworks that are going to make your API development process so much easier. Once we have documentation, we can use what I call documentation-driven development. You're probably familiar with this approach already under different names, such as design first, API first, or contract first approach. The basic idea is you design the API first and produce a specification for it, and then you build the API server and the API client with regards to the specification. And finally, you use the specification to validate your implementation. This is the high-level workflow of what documentation-driven development looks like. You go through a design stage first. Out of this design stage, you produce an API specification, and finally, you use the specification to build your client and your server. Now, let's delve into each of these workflows in more detail. So, for the backend, what it looks like. One, we're working on the backend. Obviously, we build the backend against the API specification, and then we use the specification to run tests against the backend. Now, typically, we would write these tests manually. We would build a very large test suite of unit tests, testing our API in all sorts of situations. But instead of doing that, or perhaps in addition to doing that, I want to encourage you to use frameworks that are going to make your experience testing and validating your APIs so much easier and more productive. One of these frameworks is Dredd. Dredd is an API testing framework that has been around for many years, and it's great when it comes to validating APIs. Dredd looks at your API specification, and based on that, it is capable of generating automatically tests that validate your API. Dredd is an NPM package, so you need to have an Node.js environment available locally to execute it, and running it is very easy. All you need to do is give it the path to your API specification together with the base URL of your API, and optionally you can tell it what the commands are necessary to start up your server. You can also use hook files to design and customize the behavior of the test suite, and in that case you have to tell Dredd what the language is that you're using to write your files. Let me show you what executing a Dredd test suite looks like. So here I am in my terminal, And I'm going to execute the Dredd command that I showed you before to execute the Dredd test suite. So here's the command. We execute it. And as you can see, Dredd is running approximately one test per endpoint available in the API. In this case, all of the tests are passing, but if any of the endpoints in your API wasn't working correctly, you would get to know thanks to Dredd. Now, the only limitation about Dredd is that it typically only tests the happy path for each endpoint. It's simply sending the expected payloads to the API and just validating that the API is responding with the expected responses. Before you release your APIs to production, you want to make sure that you run a more comprehensive and robust test suite against the API implementation, making sure that you're testing all possible combinations of properties, formats, types, and values for your API. Here's where a different tool comes in, which is called schemathesis. Schemathesis is a Python library which is built on top of another library called Hypothesis, which is a property-based test framework for Python. If you're not familiar with property-based testing, I highly encourage you to take a look at that. It's going to change your mind about how testing works. For the purposes of this presentation, we're just going to focus on schemathesis. To install schemathesis, you need to have a Python runtime available locally. You install the library with pip, and running a schemathesis is very simple. Just like Dredd, all you need to do is give it the path to your API specification file together with the base URL of your server. Optionally, you can also use links to run a more comprehensive test suite. Now, for those of you who are not familiar with the concept of links in OpenAPI, links are a specific syntax that allows you to express the relationships between different endpoints in your API. So here is an example of defining relationships between the post to-do endpoint of the API with other endpoints in this API. So I'm using links to say that the response of the post endpoint contains an ID property, which you can use to replace the task ID parameter of the URL of this operation, get task. And get task is simply the get endpoint for the resource URL of a task. By leveraging links, schemathesis is able to validate that you are creating your resources correctly and that the right actions can be performed on those resources. Let me show you what running a schemathesis looks like from the terminal. So as you can see, schemathesis has run over 700 tests against the API. It's used links. Links are the tests listed under this block here. And if you look at the request logs in your server, you will see that schemathesis is running every possible combination of values for each query parameter, each property in your payload, and things like that. So once you've tested your API with a schemathesis, you can be fairly certain that your API server is working as expected. Now, what does the development workflow look for the client development team? Well, in this case, we will leverage the API documentation to run mock servers, which we can use to validate the integration between the API client and the server. Of course, at some point, you want to make sure that the client is also working against the actual server implementation. But while the server is being developed, you can use mock servers to replicate the behavior of the actual server. Also, bear in mind that in many situations, the backend server may not be correctly implemented. There may be some bug in it, or there may be some error which hasn't been discovered yet. So just validating that the client works with the server is not a guarantee that it's always going to work as expected in every situation. You want to make sure you validate the client against the specification, and you do that by running it against a mock server, which runs strictly on top of the API specification. Now, you can run mock servers with various tools. If you want to run your mock server locally, my favorite tool for this is Prism. Prism is a library built by Stoplights. It is an NPM package. So again, you need to have a Node.js runtime available locally to work with it, and it's very easy to use. All you need to do is give it the path to your API specification file, and based on that, Prism will be able to run a mock server that replicates the behavior of your actual API server. You can play around with the server, calling any of the endpoints, and in every situation, you will be getting expected responses from the server. Now, if for some reason you can't run a mock server locally, perhaps because you don't have the right runtime, the right dependencies, or because you don't have enough resources to run it in parallel as you are running your API client application, You can run also mock servers in the cloud. This also allows you to share specific instances of the mock server with the rest of your team. In this area, there's myriad of services that you can use to accomplish this goal. Some of the main services are listed in this slide, and I'm going to show you an example of running a mock server with micro APIs, which to my knowledge is the only service that doesn't require you to have an account before you can actually use it. So like I said at the beginning of this presentation, using micro APIs for this purpose is easy. All you need to do is paste the API specification file in the input panel of the page, click the blue button, and you will get the base URL for your mock server. Optionally, you can also use the micro APIs API to send your specification directly to the server and get your base URL directly from the server. So if you run this command to call the micro APIs API directly, you will get a response which contains the ID of your mock server, the base URL of the server, and also a sample URL that you can use to test that everything is working fine. Interacting with the server in the cloud is exactly the same as we saw locally. In this case, you will also get perfectly valid payloads from your API, which replicate the behavior of the actual API server. Now, those were examples with REST APIs, but the same kind of functionality, we have it available as well for other types of APIs. If you're working with GraphQL APIs, you can also use API mooking libraries. One of my favorite is GraphQL Faker. GraphQL Faker is another NPM package. So again, you need to have a Node.js runtime available locally to work with it. And it works very neatly. It replicates the behavior of your API server exactly as you would expect. And it also offers you a graphical interface, which you can use to inspect the payloads, the queries and mutations available on the server, and also to write your query documents to test the endpoints. By the way, you can also use schemathesis to run test suites against your GraphQL API, looking directly at your API specification. Again, you need to have your API specification available before you can use any of these frameworks and approaches to working with your APIs. Now, we can put all of this together in a continuous integration server to make sure that we are testing and validating our APIs before we release them to production. Here's an example of how we would configure a Travis file for this purpose. This Travis file is very simple. We are simply setting up the runtimes required for our test suite. We are installing Dredd and then our Python dependencies. The example for this presentation is in Python, so schemathesis is included together with the rest of the Python dependencies. And in this case, I'm showing you how you can run both Dredd and schemathesis together within the same test suite. You don't need to use both tools in combination. You can choose one or the other depending on the requirements of your test suite and also on your stage of development. So like I said, Dredd tends to test only the happy path of your API. So if you're just getting started with the API, Dredd is a great tool to run validations at the very early stage of it. But schemathesis is the one tool that you want to run before you release your code to production. The file also contains some configuration to run an automatic deployment to Heroku. So if the test passed correctly, the code will get deployed into Heroku app. To do this, the only thing you need to do is to provide a key that Travis can use to call the Heroku API on your behalf, and also the name of your Heroku app to where the deployment has to be triggered. Let me show you how this would work in practice. So let's make a simple change to one of our files. So we just have one more line here. The div shows the line we just added. So let's just commit this and push this directly to master. So this triggers the build process in Travis. We're just waiting for the build. We're going to trace the logs here. So there you go. All the tests have been run exactly as it happened when we run the test suites in local. And now Travis is triggering a deployment to Heroku. We can monitor the deployment from Heroku here. And the deployment is ready now. We can visit this URL to make sure everything is working correctly. So let's go ahead and visit it. The base URL doesn't contain anything because we haven't defined anything for the plain URL of the server. But if we visit the documentation endpoint, we get a Swagger UI display of the API that we built using the Fast API framework for Python. Through here, we can test all the endpoints to make sure they're working correctly. So for example, we can test the post endpoint. We can execute it a few times to create a few resources. Then we can test the get endpoint to see if the resources have been created correctly. And there you go. Here we have a few resources created in the API. So we've tested that the API is working correctly. We validated that through the continuous integration process. And now we start a few better chances of ensuring that the API integration is going to work when we actually get it talking to the real client. I hope you found this useful. If you found the content interesting, please, again, feel free to connect with me, and feel free also to use the following discount code to get a copy of my book if you're interested on it as well. Thank you so much for attending, and I'm looking forward to your questions.